Hey, this is Mr. Beckstrom, and today I'm doing a problem from section 3.4. This is a request from one of the students from the forums, and they're asking us to solve this problem giving the answer in interval notation. So the first thing I want to do is just kind of give an idea of what are they asking. So we're given kind of a polynomial, and they're asking us to give all of the values where this polynomial, all the values for x where the polynomial is going to be greater than or equal to 0. So as a representation, a visual representation, if we had a graph here and we've got some third degree polynomial, maybe it looks like this, right? Everything that's greater than or equal to 0 is going to be everywhere in the graph where it's above the x-axis here. So if this was all of the area that it was above the x-axis, we'd be looking from this x value to this x value, and then again from this x value to this x value. Right, so this is kind of what we're looking for, some type of interval from here to here and then from here to here. If it went up again and then it was above the x-axis from there to infinity, then it would be from this x value all the way to infinity. And because it's a greater than or equal to, we are going to include those points at which it actually touches the x-axis as well. So this is what it's asking us, is for all of the values where it's above or equal to the x-axis there. All right, so the first thing we need to do is find all the roots, all the places where it touches the x-axis. So in order to do that, we need to use some of the skills that we have. I like the rational root theorem, although 240 has a whole lot of factors, but you know, if we use our calculator, we might be able to get lucky and get some of those pretty quick. So that's what I'm going to do here. So I'm going to go ahead. Let's put this in our calculator, and this is x cubed minus 7x squared minus 7x squared minus 38x minus 38x plus 240 plus 240. And so x cubed minus 7x squared minus 38x plus 240. So what I'm going to do is I'm just going to start. I know that 1 is a factor. I know 2 is a factor. I know 3 is a factor. I know 4 is a factor. I know 5 is a factor. I know 6 is a factor. So I'm just going to start putting in factors until I can get a 0 in there, and I know that that's a root, and then I can use synthetic division, get this thing reduced down until I can get to something more manageable. So if I do that, and I go ahead and make sure second window, ask and auto, go to my table, and delete these out. So it doesn't look like I'm going to have an easy one, does it? So -1, nope, 1, -2, 2, no, -3, no, 3, how about -4, 4, -5, 5, oh, I got a factor. Let me go ahead and try a couple of more. -6, just to see if I get lucky. Oh, look at that. I got 2 of them already. 6. And let's try 10 and -10. 10, -10. Well, I'll take, which ones did I get here? Oh, I thought I had 2 of them, didn't I? Oh, it only goes up. So wait, I had, which ones did I have? I had 5. So let's go ahead and then, oh, and then I had 6, -6. So I have 5 and -6. I know both of those, so I'm going to go ahead and use those right away. And so I know that these are both roots. And I just did this because remember the P over Q So P over Q, where P is all the factors of 240 and Q is all the factors of 1. And there's tons of factors in 240. I could have listed them all out and divided them by all the factors of 1, which is just 1 and negative 1. Like I said, I just wanted to start testing them to see if I could get a few out of the way, which I did. Once again, I know that x is equal to, what was it, 5 and negative 6. So right away, I got lucky, and I found a couple of those roots. So let's factor out the 5, or use synthetic division. So I have 1, negative 7, negative 38, and 240. All right, so bring down the 1. 1 times 5 is 5. Add those, you get negative 2. 5 times negative 2 is negative 10. Add those together, you're going to get negative 48. 5 times negative 48 is negative 240. Bring those down and you're going to get 0. So if I pull out x minus 5, that's the factor, that's the using the root 5, I am left with x squared minus 2x minus 48 is equal to 0. And at this point right now, I could either use synthetic division, pulling out the negative 6, or I can simply just factor this, which is what I'm going to do. So I have x minus 5, and I already know that I'm going to be able to use that 6 in there, right? So x, right, and x, I wouldn't have had to go very far in the calculator to find the other one, but so this is going to be a plus 6 and a minus 8, right? To get that negative 48, and add those together to get that negative 2 there. So my last one is going to be a positive 8. So these are my 3 roots. So these are the places where it at least touches my x-axis. So if I have this line here, my smallest one is negative 6. My next one is 5 over here. And then my next one is 8, right? In that order. So negative 6, and then 5, and then 8. So the test point method says I can take any test point in each one of these intervals, so 4 intervals, and see if I'm positive or negative. Because I either have to be positive or negative, because the only place that's going to equal 0 is actually at these 3 points. So at any other point, it's either got to be positive or negative. And anywhere it's going to be positive, that's what I'm looking for, because that's going to be greater than or equal to 0, right? So I'm going to do it 4 test points, and I can do that easily with my calculator, right? So let's go ahead and delete all these out. We can use the same exact table that I used before, and it should change at each one of these. Why? Because my multiplicity is 1, which is odd, which means that it crosses through at each one of these points, because I only have one. Each root only occurs exactly 1 time, and 1 is an odd number, so that means it's not just touching the point and going back in the same direction, it's actually crossing through. So I shouldn't go from positive and stay at positive. I should cross through. So if I'm positive here, it should go to negative. So if I stay the same sign, I did something wrong. So let's first just pick any number that's less than negative 6. So let's try negative 8. And I get a negative number. So I'm just going to put a minus sign right there. And I'm going to pick some number between negative 6 and positive 5. I'm going to pick something easy, 0. And sure enough, I get a positive number. Just a little positive there. And now I'm going to pick some number between 5 and 8. Let's pick 6. And sure enough, I get a negative. And then any number greater than 8, I'm going to be a little wise guy here and pick 1,000. And I get a positive number. That's e to the 8th, which means you have to move that decimal place 8 places. Let's pick 9 just to show you that it's still a positive number. So that means I'm going, so here I'm below the x-axis, and then after -6 I'm above the x-axis, and then between 5 and 8 I'm below the x-axis, and then after 8 I'm above the x-axis. And if we look at the graph, and graph this thing, sure enough, see, oh, I am, do I have the, all right, so, oh, I think I have, let me go to Zoom Standard. I think I left it in that last, there we go, see, up until -6 I'm below, and then from -6 to 5 I'm above the x-axis, and then from 5 to 8 I'm below the x-axis, and then after 8 I'm above the x-axis. So in interval notation, I'm looking for everywhere that I'm greater than or equal to 0. So I'm greater than or equal to 0 from, remember I'm including everywhere I'm equal to 0, so I use brackets from -6 all the way to 5, right? Because I'm above the x-axis from there to there, and I'm also above the x-axis from there to infinity, right? So also from 8 to infinity, and we never include a bracket with infinity. We always put a parenthesis with infinity. So it should look like that. So this is the interval notation for the solution set for all of the x values where I'm greater than or equal to 0. And what does that mean? That means as long as, let me go back to my table, as long as I put in any of these values here, any one of those, it's going to give me a value that's greater than or equal to 0. So just try it. I'll put in a 2. Is 2 in there? Yes. So if I put in a 2, it gives me a value that's greater than or equal to 0. If I put in something that's not in those intervals, like a 7.3, which is not in the intervals there, it's going to give me something that's not greater than or equal to 0. If I put in a -11.4, which is not in those intervals, it'll give me something that's not greater than or equal to 0. So that's what it works. All right, I hope that helps. If you have any questions, let me know, and I hope you have a great rest of your week. Thanks.